Okay, I want to pick up. I want to pick up reviewing where we left off yesterday. Namely, it says, let's just go over example 2 again. Do you remember what it means if you have the negative after the number? Yeah. So it says the limit as x approaches negative 4, and that's from the left. And again, you're wondering the output. So what was it again? What did we say? What's the limit? 3. And if you approach negative 4 from the positive, that's going to be negative 2. So those aren't the same, are they? And so I don't know how this got here, letter E, but I'm going to jump there right now. Look at how E, oh, this is positive 4. Okay, we're just going to scratch it off like we did before. Okay, so C says the limit as x approaches negative 1 from the negative. So from the left, that would again be a value of 4. And from the positive, again, a value of 4. Yep. Right. So finally, and this is where we left off, and this is the key point for your learning today. The limit as x approaches 2 from the negative. So from the left, you said was negative 1, and the limit as x approaches 2 from the positive was positive 5. But the limit as x approaches 2, period, so not from the left, not from the right, but just the limit as x approaches 2, we say does not exist. They're different. Exactly. That's the idea. So the informal way we're going to understand a limit is that if the left-hand approach is the same as the right-hand approach, then the limit exists. But if the left hand is different from the right hand, then the limit does not exist. As x approaches negative 1, the limit does exist. How about the limit as x approaches positive 4? Does that exist? It does. It's not evaluated at 4, but they both approach a value of 2. So you can see if I approach from the left, I'm approaching a value of 2. If I approach from the right, I'm approaching a value of 2. Is there actually a value there? No, but that's okay. So let's write this down. The formal definition of a limit as, and this is, it says formal. It should really say a formal definition. It's not the formal. I made these notes before I decided to entertain them. Kind of a more interesting portion, which we're going to get to next time. If and only if the limit as x approaches a from the left of the function is equal to the same thing, the limit as x approaches a from the positive of the function are both equal to the same thing. Okay? So if the approach from the left is the same as the approach to the right. It says, note that f of a, so if we actually plug that value into the function, if we plug a in, we may not actually get the same value as L. So that's my point right here. If you plug in 4 to the function, what's the result? There's nothing. There's no value there. But yet there is a limit. So that's something to keep in mind. Okay? All right. So let's. It says use a table to determine the following limits. So I'm going to show you the first one without a table so that you can understand. But can I plug in 2 right now to evaluate this? No. What could I use with algebra to do it? I could pull it apart. X minus 2 times x plus 2. And what will cancel? X minus 2. So really you have the limit as x approaches 2 of x plus 2, which would be 4. Now, do take out your calculator because I want you to see how you actually do this with a table because it's a little bit different than what we've looked at before. So please take out your calculator. It changes on its own. So yeah, yeah. Oh, you thought I changed it every day. Yeah. I don't have anything to do. I just yeah. Really? Yeah. I like that. I like that. All right. I'll take that as a compliment. Um, so what I do is I plug in my function, and so what I want to do is I look at the table. I want to approach 2 from the left. If you want to approach 2 from the left, what numbers do you plug in? No. Numbers smaller than 2. Give me a number smaller than 2. 1 would be fine. What after 1? 1.9. What after 1.9? 1.99. 1.999. So I'm approaching it from the left. Does everybody understand why? What is the value approaching? 4. The limit is approaching 4. Now, let's approach it from the right. We go to our calculator. What are you going to put in to approach from the right? 2.01. Sure, 2.1. 2.01. 2.001. Good ideas. What is it approaching? The limit. 4. So is that the same as the right-hand side or the left-hand side? Yeah, they're the same. So therefore, we can confirm it. So that's how we use our table. Now, let's look at a different one. This one's more difficult to deal with. So every time we do an easy example, there's always a more difficult one to examine. So sine of x over x. Do you think we can deal with that algebraically? No, you got no chance. So, well, not that you know right now. Later on with more calculus, we actually could, but that's for another time. So let's go to our calculator, and as we go into y equals, I'm going to type in sine of x, and I divide that by x. You can't plug in 0 either, otherwise you would get an undefined value. So what I'm going to do here is I'm going to go to my table, and I'd like to plug in values close to 0. I'm going to approach from the left. What should I plug in? Negative 0.1. That would be a good idea. Negative 0.01. Negative 0.001. What do you think? It looks like it's approaching 1. So my x values are trying to approach 0. So I did that from the left. Now we'll do it from the right. 0.1, 0.01, 0.001. And that appears to be approaching 1 as well. So does the limit exist? Yes. So sometimes you can't use actual algebra. You have to use a table. So it equals 1. We confirm that by the table. Does that make sense? Got to go from the left and the right. Okay, flip it over. So this is our last set of limits to look at. The limit is x approaches 0 of 1 over x to the fourth. Do you know what the graph of 1 over x to the fourth looks like? It's undefined at 0. And in fact, if you were to graph it, you get this type of shape. Let's go to our calculators and let's plug them in. Okay? I'm going to type in 1 divided by parentheses x to the fourth. And I'm going to go to my table. If I went to graph, it would look just like that. Let's understand what this function is doing. Again, I want to approach 0. I'm going to do it a little bit more slowly than what we did before. Here's a number that's close to 0, negative 1. The y value gives me 1. How about negative 0.5? What does the y value give me? What's happening to the value? It got bigger. Look at what's happening in the graph. It's getting As you approach 0, it's getting bigger. Let's plug in something even closer. Let's go negative 0.2. Ooh, wow. So can somebody tell me when I plug in negative 0.01 and I get really close, what is this 1e8? 1 times 10 to the 8th power. So what kind of number is that? It's really, really, really large. So what do you think as x approaches 0, what do you think the limit's approaching? Very good. The limit does exist. They are both approaching infinity. Let's look at the next graph. You guys, if you don't know what a graph looks like, if you don't know exactly what that looks like, then what you're going to have to do is you're going to have to type into your calculator to get an idea. So, whoop. Okay, where's this function undefined? 1. So if you look at this function, does everybody agree it looks like this? So now instead of looking at the table, we'll see if you can figure this out by looking at the graph. I'm going to approach 1 from the left. What is the output approaching? Negative infinity. Now I'm going to approach 1 from the right. What is the output approaching? Does the left equal the right? No. Say it. The limit does not exist. Thank you, Mean Girls. Thank you, Lindsay Lohan, who is now on lockup, right? All right. Well, not for long. Uh, we've heard this story many times, so. Megan has a very good question. Everybody listen so we can hear the very good question. People. So if it's approaching two different things. So here they're both the left and the right approach infinity. Here one's negative and one's positive, so therefore the limit does not exist. Excellent. Okay. All right. So last thing is this, okay? Um, we don't really need to fill this out here, okay? Other than this part. The limit as x approaches a of f of x equals infinity, what that means in plain terms is as x approaches a, the output gets really big. Infinity is a very difficult idea to talk about sometimes, and so it is an extremely large number. And as soon as you think of an extremely large number on a number line, there's a there's another number that's infinitely larger than that, as much as you can wrap your brain around that. So as x approaches a, the output gets extremely big, okay? And that's what that idea means. So you always involve limits of infinity anytime you have what we call vertical asymptotes. So that's the last thing I want to do. As you look back at your original function right here for letter A, what is the vertical asymptote? X equals 0. Very good. You have a vertical asymptote where the function is undefined. That's not always the case. Just because it's undefined in the denominator doesn't mean it's going to have a vertical asymptote. Remember yesterday where we were undefined in the denominator, but it was a dot in the middle? Remember that? Wasn't that cool? And then we graphed our calculator, we saw the missing pixel. That was really cool. I thought about that all day yesterday. I was so happy. That just made my day. It was so cool. Um, but this one does. We graphed it. So how about this one? Oh, it looks like I pressed something and something happened. Yeah. All right. Okay, there I've got it back. Okay, now this function right here, what's the vertical asymptote here? X equals 1. So so we had x equals 0 and x equals 1. Those are vertical asymptotes. We had issues involving infinity there, okay? You can also have one that goes to negative infinity. So with that said, that's all I have today. Today we get out at 11:02, which means you have a lot of time. Um, I think we might have some uh, time to work tomorrow as well. So I think I want to put together a worksheet that involves the ideas of limits as well as what we covered in 2.1 to kind of tie your learning together a little bit. So we'll take a break from notes tomorrow, I promise. But let me put your assignment on the board. Yes, you may. So Tyler Vandenhoevel, this is for you. So that's the assignment. Just as you look at the notation in your book, remember this is a left sided limit. This is a right. This is both left and right. And this notation means simply evaluate the function at -1. So what's the output at -1? Good luck. See you soon.